Now, sometimes we have graphs that are used deceptively. So we're going to look at some examples of that. And I should say deceptively or just ineptly and improperly. Here is a pie graph that doesn't add up to 100%. So this should have been done as bars and not pies, because pies always have to add up to 100%. Here are some bar graphs and pie graphs that have been drawn in sort of a three-dimensional angled look to make them look cool, but they're deceptive when you do that, because the orange and the turquoise bar should be the same size, but this makes it look like the orange is a lot bigger. Here, the green slice should be less than the blue, smaller in size than the blue slice, but the angle makes it look bigger. So don't draw a graph to look cool if you're doing presentations for a company sometime later in your life. Make sure that your graph, the area shown is accurate to it's representative of the true percent. Here's another way that graphs can be inaccurate, is to have a misleading scale. Here we see in week 1 a person, the average cholesterol was 208, and then after eating oatmeal for 4 weeks it dropped to 198. Wow, it's like a third of what it used to be. Really? No, not really. It's just a few points different, but the graph makes it look like an extreme change. Here's what the graph would actually look if you started at 0. Now, did the cholesterol drop? Yes, but not as extremely as the company made it look. So they were actually sued and told that sued for false advertising with their exaggerated health claims about oatmeal. Here's another graph that's very similar. 82% on this stack, 75% on this stack. 82% isn't 3 or 4 times the size of 75%, so this is a misleading graph as well. Here's a third example where if we just looked at the heights of the people, the 27%, the 16%, the 12%, and just looked at the height of the doctors, they probably would be pretty accurate. But since they are drawn three-dimensionally, or two-dimensionally, sorry, not just a single bar, you have to look at the whole area of the figure, and this area looks like it's a whole lot more than twice as big as the little doctor. It looks more like 4 times bigger. Here's a case where the scale gives different information depending on how you label it. So this is the increase in global temperature since 1880. So if you look at the graph drawn from 0 to 120, we're seeing very slight increase. It almost looks like there was no increase at all. If you zoom in on it a little bit, you can see that there is maybe about 1.5 degrees increase. So both of them, this kind of gives a big picture, but this is really because the global average temperature is not going to be anywhere close to 0 or 120 in most places. So this is going to be a more probably meaningful graph for this data. This is just a weird graph. If you look at it, it shows that something seems to be improving. But if you look at the percentages, nothing's getting bigger. They're all about the same. So it gives you some illusion that the Sotheby's and Christie's auction houses are increasing their share of worldwide sales when really nothing is happening at all. This would be a more accurate graph of what's happening with those two companies and their worldwide sales. Then we have this graph. Gun deaths in Florida, number of murders committed using firearms. And the scale goes from 0 at the top to 800 at the bottom. So it's really confusing to know, like we think of this being an increase, but it's actually a decrease. So are the deaths increasing or decreasing? It's hard to tell. It's upside down. So it's telling us, it's giving us a false impression of what's really happening. And then here's an interesting one. What should cost less, a gallon of gas or a gallon of milk? 43% yes, and 57% said no. Huh? What's going on with that? So to summarize, when we're talking about graphs, the bar, the wedge, the pictograph is when you use a picture like the books or the doctors instead of a bar. The area of the bar, wedge, or pictograph must be proportional to the actual quantity represented. And we saw that many times that it was not. And don't use unclear or misleading scales on your graph. That was the other area that we saw created a lot of deceptive, misleading, or confusing graphs.